Okay. Psst. Fix one thing just to make sure we're good with that. Psst. That A value that we were struggling with, or that I was struggling with a little bit. Okay. The best, I told you guys, it's kind of hard to tell A because it stretches and shrinks, and it's only going from here to here, infinity. So it's almost impossible to tell if it's stretched or shrink because it's still going to infinity. And if you stretch infinity, it's still infinity. If you shrink infinity, it's still infinity. So the only place you can really tell the A value is like that little squiggly mark. Okay? So what you're going to end up doing for A, just to look at 2 points, look at the change in concavity, concave down, concave down, concave up. So that change in concavity, most of the time that's on the y-axis, x-axis. Most time that's on the x-axis, unless if it's moved up or down. And then you look at the asymptote. So you look at the asymptote and the change in concavity and look halfway between that. Halfway between that should be 1. Should be 1 away. Halfway between there and there, that should be 1. If it's 1, then the A value is 1. If it's 2, then the A value is 2. If it's 1/2, then the A value is 1/2. Okay, that's the only place you can really tell if it's stretched or shrunk. Y'all okay with that? That halfway point is the pi over the 4. That's when sine and cosine are the same number. That's when sine and cosine are the same number. So normally that's 1 because it's square root of 2 over 2 over square root of 2 over 2. But if A is 2, then that number is 2. If that number is 3, then A is 3. So what I mean by that is you look at where that concavity is and the asymptote, and you look at halfway between that. And then you look to see how far away that, I don't know, that value, that is from the x-axis or from the concavity if it's moved up or down. A value is 1 there. Of course, that's the parent. There's the concavity. There's the asymptote. There's halfway. That's 1. A is 1. Okay? Here's the concavity. Here's the asymptote. There's halfway. That's 1. Most of the time, it's 1. Because, again, it's really hard to tell if it's not. But that's about the only place you can really tell if it's not 1. Go to the inflection point, go to an asymptote. And you can go to any one of them. It doesn't matter. I can go to this one, to this one, this one, to this one. But you go and then go halfway between it and look to see how high up that is from the inflection point. And if it's just up 1, then A is 1. If it's up 2, then A is 2. If it's up 1/2, then A is 1/2. And sometimes it's just going to be an estimate. Okay? I mean, you can't tell the difference between 1/2 and 1/3. Okay, everybody okay with that A? That was an issue that I had Monday that I thought was pretty easy, but then when I got up in front to get to teach you, it wasn't. I froze up. I locked up. Any questions over that homework assignment? I did not post the answers because I didn't even post the stinking assignment till late. Anything on that question, on tangent? Tangent's not used near like sine and cosine. It's not used near like sine and cosine. And if you notice today when I had the notes pulled up, we're going to jump to 11 today. We're going to jump to 11. So we're going to skip, what, 10 and 9 and 10. We're going to skip 9 and 10 for now. For now, 10 is huge. I think we're going to spend about 3 days on 10. 3 days on 10. Couple days on 12. 1 day on 9. 1 day on 11. I think you'll see why we're doing 11 today. It just flows better for for me, for sure. We're going to talk about secant, cosecant, and cotangent. Secant, cosecant, and cotangent. And if you can do sine, cosine, and tangent, there is no doubt that you can do secant, cosecant, and cotangent. Okay? So, here we go with that. Secant, cosecant, and cotangent functions. Just when you thought the trigonomic functions couldn't get more exciting. Today, we have to learn about 3 additional trig functions. We've kind of mentioned them a little bit in class already, but now we'll talk a little bit more about them. The good news is that while these are 3 new functions, they correspond to sine, cosine, and tangent, which is a little crazy because to me, tangent corresponds to sine and cosine. If you know sine and cosine, you know all 6 of them. If you know sine and cosine, you know all 6 of them. So these new functions should not be too difficult for us to incorporate into our existing knowledge and quickly understand the ideas behind them. I hope. So the biggest thing you need to know about secant is that secant is the same or the reciprocal of cosine. Secant is the reciprocal of cosine. And I know when I first started hearing about this, I thought that was weird because we have secant and cosecant, but secant goes with cosine. Cosecant goes with sine. And I don't know why that is, but that's what they did. So we just have to go with what they did because we weren't smart enough way back then to come up with it first. Good enough? So secant, S-E-C. And the way that I remembered this all throughout high school is that cosine. See how that's kind of just revipped of cosine other than the E and the O. So secant and cosine go together. And all they are is reciprocals. They're reciprocals. So when cosine is 1, secant is 1, because you flip a 1 and you get a 1. When cosine is 0, secant's undefined. Because when you flip a 0, you got a bad number. Just kind of think about that. We'll go through it, but just kind of everything else, we're just flipping things. 1/2, we're flipping to 2. Square root of 3 over 2, we're flipping to 2 over the square root of 3. Square root of 2 over 2, we're flipping to 2 over the square root of 2. You're just flipping everything. Reciprocating. Not really flipping, but okay. Cosecant goes with sine. Cosecant goes with sine. And again, how you remember this, I have no idea, but why does cosecant not go with cosine? But it doesn't. You'll learn some tricks about that through calculus too. But anyway, cosecant goes with sine. So secant goes with cosine, and again, I just flip those to help me remember. If I flip that C and the S, then I got cosine. That one, if I flip a C and a C, I still have cosecant, and so that's I don't know. If you know this one, then you know that one. And then, of course, cotangent is the flip of tangent. Not only is it the flip of tangent, but it's cosine over sine. So you can do that either way. If you know what tangent is, then we'll just flip tangent. But if you don't know what tangent is, which I don't, I just flip sine over cosine and make it cosine over sine. Good enough with that. Those 3 trigonomic functions, get them in your head, just understand that. These are not, they're not used that much because, again, they're just sine and cosines. Those are the ones that used. Okay. The graphs of each of these reciprocal functions will include vertical asymptotes. It will include vertical asymptotes because sine has a 0, and if you flip a 0, you're undefined. Cosine has a 0, and you flip a 0, you're undefined. Okay? So their graphs look a lot different than the sines and cosines. Secant goes with cosine. Well, you already know, or I hope you know, looking at your exams, most of you know that cosine starts at 1. Where am I at? I start at 1. And I come down to 0 and I go down to -1. And I come back up to 0 and I go back up to 1. And I come back down to 0 and back. So cosine starts at 1 and then comes down and looks like that. That's cosine's graph. That's cosine's graph. Well, every time cosine is 0, that's an asymptote for secant. So when cosine is 0, that gives me an asymptote. It's an asymptote. Every time cosine is 1, secant is 1, because you flip a 1 and you get 1. When it's -1, it's -1. So we're looking at those maxes and mins, if you will. And from that, if I start flipping and flipping and flipping, it becomes a really, really, really big number, because this is becoming a really, 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 really small number. And if you flip a really, really, really small number, you're going to get a really, really, really big number. And so they're shooting up this way, and they kind of look like little parabolas. And you're just staying in between the asymptotes. And when you're down here at -1, you're just flipping them down this way. And that happens with sine, cosine. Well, let me rephrase that. That happens with secant and cosecant. You look at the maxes and the mins and shoot them up at the maxes and shoot them down at the mins. And you look at the zeros and you make asymptotes. Here's cosecant, which is sine. And here's sine. Starts at 0, goes up to 1. So sine looks very similar to cosine, except it starts at 0, but every time we have 0, we have asymptotes. So we have asymptotes. And every time sine has a max, we're going to shoot it up in the parabola, and every time sine has a min, we're going to shoot it down in the parabola. Hit me.
If it's not being shifted at all, the vertical axis will just be on the period?
On the origin, yes. If we're not shifting cosecant, then it starts at 0, because sine is 0 at 0. Sine is 0 at 0. So if sine is 0 at 0, then cosecant must be an asymptote at 0. Everybody okay? Kind of soak all that up. So if you know sine and you know cosine, which again, looking at your test, most of you do, then you know secant and cosecant. And you have the same shifts. Same shifts left, right, up, down, shrink, compress, shrink, compress. So I don't think I have ever graphed cosecant in my head. And I don't think I have ever graphed secant in my head. If I see secant, I immediately just graph cosine and just flip everything. When I see cosecant, I just graph sine, just like you guys already know, and I just flip everything. Good enough with that? Cotangent is a little bit different. Oh, let's read what they say about all this, because that's important stuff. Note, the graph of secant has vertical asymptotes where cosine equals 0, pi over 2, and then they add pi k to that. Every pi k is an asymptote. I know, I confused you now really bad. I think I got one way up here, but you can put it wherever you need to. I want to confuse my stats kids. They got a test today. That's what it's for. Nothing to do with you guys. So, this is a notation that you need to be somewhat familiar with, okay? Pi over 2 is where the asymptote is, unless we're shifted. We can shift up or down, it's not going to change it, but we shift left or right, or we change the period, okay? Then we're going to add a pi k to it, because every pi after, wherever the asymptote is, every pi after that is an asymptote. Every pi after that. And then k is just an integer. So K is some integer, and that they just always use K. They'll always use K. When we start solving for these things, that'll make a little bit more sense to you. But I can't list all the asymptotes. I can't list them all. So we have to do like that generic pi K at the end. Okay? The pi K at the end. Sometimes it's 2 pi K. Sometimes it's 1/2 pi K. Same thing over there. It starts at pi for sine. Sine is, pi is where it's 0. Cosine is pi over 2, because the dog doesn't go anywhere. And 3 pi over 2, which is pi away. So pi over 2, pi away, pi away, pi away, pi away. Whereas sine is 0, pi away, pi away, pi. Uh-oh, sorry. The ranges go from negative infinity to -1 and -1 to infinity. They are undefined from -1 to 1, provided we're not moved up or down. Whereas sine and cosines, the ranges were only defined from -1 to 1. We never got smaller than -1, and we never got bigger than +1 unless we're doing some shifting. So now, these are undefined from -1 to 1, and they go the opposite part, negative infinity to -1 and 1 to infinity. Both sine and cosine. Both sine and cosine, or both secant and cosecant. Okay? Beautiful. And then tangent or cotangent. Tangent and cotangent. So tangent, we just got a little bit of the other day. It kind of looks like a cubic function. It starts low, hits the inflection point, goes high. Starts low, hits an inflection point, goes high. That's tangent. Cotangent does the flip of that. It starts high, comes down, hits the inflection point, and goes low. But it doesn't hit the same inflection point, it hits it over. Because it's cosine over sine, and that's where sine can't be 0. So cotangents actually have the asymptote at the y-axis. Cotangents are shifted of tangents in more ways than one. Not only are they shifted right or left, but they're flipped. From instead of looking like this, they look like that. Soaking that in. There's a lot of page turn. I know that it's jumping around with your notes. Everybody okay? Everybody caught up? Follow along? So, the graph of cotangent has vertical asymptotes where sine is 0. So kind of keep that in your head, because cotangent is cosine over sine. That's bad. We can't have sine be 0. If sine's 0, then it's undefined. So that's where their asymptotes are, when sine is 0. Those are the type of questions they're going to ask you. Where are cotangents, where are the asymptotes for this function? And it'd be a cotangent. And it'd do some shifting, left, right, up, and down, and whatever it might do. So as soon as I see that, I say, well, I don't know where cotangent's 0 or undefined, but I sure know where sine is. And if I know where sine is undefined, then that's where cotangent, or let me rephrase that, where sine is 0, that's where cotangent is undefined. Tangent's undefined when cosine is 0, because it's sine over cosine. Secant is undefined when cosine is 0. And cosecant is undefined when sine is 0. And if you know all that stuff, you're pretty good with these questions. Because, again, those are the type of questions they're going to ask you. Where are the asymptotes? Where are the zeros? Draw. Example at number 1. Example number 1. F of x is equal to 3 secant 2x. 3 secant 2x. I don't look at secant, I look at cosine. So I'm immediately thinking 3 cosine 2x. Immediately, that's what I'm thinking. Because I know sine and cosine, and I don't want to have to learn 6 of these things. If I only need to know 2 of them, that's all I'm going to do. Which of the following has a vertical asymptote? Vertical asymptote. Well, a vertical asymptote happens when cosine is 0. And a 3 has nothing to do with it because all 3 does is change my amplitude from -3 to +3. So that has nothing to do with a 0. The 2 does, because the 2 changes the period. It's 2 pi over b. So the period is pi. And if you have to, draw it. Draw it. Sketch it. Cosine starts high, goes low, hits it, comes low, goes back up, hits it, comes back up. Just draw it. Quick sketch. This is 3, this is -3, but that doesn't matter. This is the value I have to find. And my period is pi. So instead of this being 2 pi, that number out here is now pi. And halfway between that has to be a half a pi, which is down here. And halfway of the halfway has to be a fourth. 1/4, 2/4, 3/4, 4/4. 1/4, 2/4, 3/4, 4/4. So 1/4, which is pi over 4, pi over 4, pi over 4 is C. If pi over 4 wasn't a choice, I'd have to go out to somewhere else. 3/4. And I bet 3/4 is not a choice. Amazing. They'll never have 2 possibilities. Y'all okay? Questions? Kind of see how I did that. I think a sketch will help you on these. I think a sketch will help you. I don't have to think about any of this stuff right here except just thinking about flipping the cosine. I got a 4. I got a -2. I got a cosecant sine, and I got a pi x. Which of the following is a vertical asymptote? You're kind of getting the idea of this, right? What do we know about that 4? Has nothing to do with a vertical asymptote. That just shifts the whole graph up 4 units. And if you move a vertical asymptote up 4 units, it's still an asymptote. That 2 has nothing to do with it because that 2, all it does, stretches a vertical asymptote. Hit me. Glad to help. Good.
I was thinking there's a negative.
Not yet. The negative won't even matter. Yep. You okay? Good. So the 4 has nothing to do with a vertical asymptote. The 2 has nothing to do with a vertical asymptote. The negative, well, it's a negative. So if this is cosecant, I'm going this sine, sketch it. Sine starts at 0. Normally it looks like this, but that has a negative. So we could actually get this one wrong and still get it right, because the negative still hits 0 at the 0. Still hits the 0 at the 0. Now, if you want to be nice and pretty about all that stuff, we'll do it. But I'm looking at these stupid 0 things because it's looking for the vertical asymptotes. The period is changed. So it's 2 pi, right? The normal is 2 pi, and we put that over the b value. B is pi. So the period is 2. 2. So this is 1. Bless. And that's pretty easy because I don't need anything else between these. So it's either going to be a 1, or it's going to be a 2, or it's going to be a 3, or it's going to be a 4, or it could be a negative 1. D. I will get some students try to put B. Okay? But it's pi over x. And 2 pi over pi cancels the pi's. And so it's just 2. Just 2 is the period. And so it hits a 0 at 2, but it also hits a 0 at 1, and it hits 1 at 3, and it hits 1 at 4, and every k value after that. Not a pi k or 2 pi k, or just a k. Let h of theta 3 cosecant. Which of the following gives the range? Different question. Cosecant goes with sine, but I don't think it even matters because the range is the same for sine and cosine as well as secant and cosecant. So you can miss some of this stuff and still get it right. That 3 has something to do with the range because that's the amplitude, and the amplitude is going to bounce between -3 and 3, except this is not going to bounce between -3 and 3. It's going to be everything but -3 to 3. The the theta over pi just shrinks this thing up and down, and that has nothing to do with the range. That has to do with the domain. And all these domains are negative infinity, infinity. So if this is cosecant, that is cosecant goes with sine. Sine looks like this, but we're going from 3 to -3. And if this is going from 3 to -3, that has to mean that cosecant is going from -infinity to 3, -3, and 3 to infinity. Letter D is for sine. Letter D is for sine. Letter A is for cosecant or secant with no amplitude. Letter B is secant or cosecant with an amplitude of 2. Easy questions, I hope. Which of the following is a vertical? You're starting to get an idea of this, yes? These are going to be multiple choice questions. They're not going to be your free response questions. These are going to be multiple choice questions. They're going to have 1 or 2 of them at the max. Why are we spending all day on it? Because they're easy and you want to get as many points as you can. And so don't miss these. Which of the following is a vertical asymptote for cotangent? Cotangent. Oh my gosh. Okay, start thinking. Cotangent. Sine over cosine. No, it's cosine over sine. Cosine over sine. Cosine over sine. Bless you. Cosine over sine. So I worry about when sine is 0. And I'm going to just graph sine really quickly. I'm going to graph it. Just quick picture of sine. This will help you throughout anything. Boom, boom, boom. There's sine. Sine starts at 0, ends at 0. I know, I'm blocking everything. Okay. The -5 just flips things from -5 to 5, which doesn't affect my zeros. All that 5 will make this now a 5, and this make this a -5. And really, the -5 doesn't make it look like this. It makes it look like this. But again, that does not affect my zeros. So you're kind of nice. A lot of these things, it doesn't matter what they put out there. It doesn't affect the zeros. The 2 pi does affect the zeros. It's going to change my period. And so I got to put 2 pi because 2 pi is my constant, over b, which is 2 pi. Holy cow, that's really, 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 really nice. The period is 1. So when I start here at 0 and I get out here to 1, I've done a complete cycle. And that must mean that 1/2 is my other 0, which is letter B. Letter B. What else do we have? In the xy plane, what are the x coordinates of the points of the intersection of the graphs of, oh my gosh, now this might be a calculator question. I don't know. It doesn't have one. I don't think it needs one because it's got good numbers. Let's look. So we got f of x here, f of x, and we have g of x. And g of x is nothing more than 11. So that's a constant at 11, just going straight across at 11. Straight across at 11. In the xy plane, what are the x coordinates of the points of the intersection of the graphs of f and g? And all they care about is from 0 to 2 pi. Because you guys are smart enough to know that this thing goes on forever, and it can intersect 11 forever amount of times. And there's 2 ways to go about this, and I don't know which way is better for you. Cosecant, 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 sine. Sine. Normally starts at 0, but this thing is shifted up 3 units. Up 3 units. So it's going to start at 3. I don't have any negatives, so it's going to start going up, coming down, going back up. I'm going to go ahead and just draw it. I probably hit the x-axis at the wrong point. Not probably, I did. But I don't care. It's my new x-axis. If this is 3, it's supposed to go up to 1, but this is going up 4 units. So if it's going up 4 units, 3, 4, 5, 6, 7. 3, 1, 2, 3. I should have came down here to -1. So I could have done that a little bit better. Could have done that a little bit better. Is that ever going to hit 11? Oh, it's cosecant. Oh, it's cosecant. Sine's not going to hit it. Asymptotes. 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 Yes. Yep. Yeah, they're still there. That's the new 0. Y'all here understand this question? And that's my new 0. That's still the asymptotes.
The sign happens before you move it around.
Correct. And so this actually starts here and goes up. So I'm going to hit 11. This starts here and goes down. I'm not going to hit 11. Not going to hit 11. This is 4. No, this is 7. I got to go up 4 more? I don't know where I'm supposed to know I'm going to hit that. The amplitude? That's 7, yes? 8, 9, 10, 11. There's 4 more. Oh, now I'm getting it. Now I'm getting it. 4 more. Well, how do I do this? What's sine of 1/2? Y'all with me? When is sine 1/2? That's what I should say. Y'all with me on the unit circle? Yeah, you fart heads. I told you guys. Sine is 1/2 when it's short, right? Sine is 1/2 at pi over 6. Flip 1/2. 2. But that amplitude is 4, which makes it 8, 9, 10, 11. Shift it up 3. Huh. It's also 1/2 where? 5, 6. Whew, we made something pretty easy, pretty freaking hard. I see why we did this first now. That's awesome. Those are the only time you can flip something and make it nice is the 1/2 on the ones or the zeros. Those are the only flips you can make to make them nice. Because if you try to flip root 2 over 2, you're going to get 2 over root 2, and that's not nice. That's not nice. And you need to know that sine of 1/2 happens at pi over 6. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6 is also 1/2 because that's how high the duck is up in the air. Same time, it's both 1/2. And so it happens here at pi over 6, but it also happens over here at 5 pi over 6. And that's when it's going to hit 11 up here. Because you flip 1/2 and you get 2. But that 4 is going to double it and make it 8. But then I'm also shifted up 3 units, and now that makes it 11. 8, 9, 10, 11. If there were any other numbers, I wouldn't have any idea how to do this except with a calculator. Any other numbers, I would not have any idea how to do this except with a calculator. Ooh, there's a calculator. Let h of x equal 3, 1/2 secant x, and k of x equal 4. In the xy plane, where the x coordinates of the points of the intersection of the graphs from 0 to pi over, 2 pi over. So I'm looking at almost the same question. Same question. Here we go. I don't draw the x-axis yet. Secant, cosine. Secant, cosine. Start up here. Go down. Go down. Come up. Come up. Cosine. Cosine. That should be my x-axis. But this thing has moved up 3 units. It's moved up 3 units. So if this is my x-axis, I'm actually going to move it down 3 units. 1, 2, that's 0, that's -1. I should be down here. 3. This is 3. This is 4. This is 2. I'll let y'all catch up. I don't care how you do it. I'm just telling you the way I do it. You could draw the x-axis and then shift it up. I don't care. You need to know that this is a 3. You need to know that that's a 4. And you need to know that's a 2. Oh, no. What else? Oh, I did a 1/2 then, too. That's not the period. That just shrinks at 1/2, yes? So now this is not 4. This is now, uh-oh, hit me.
I think that what we're trying,
It's going to be,
setting h of x equals k of x.
Yeah, I was going to do it that way. I was going to show you that after. Slow down. Dork. Stop! I was going to do that. I was going to do it on the last one too. Start calling you Pin. Pop my bubble. Okay, somebody already spoiled it. Somebody already spoiled it. Don't try to figure out when that's 11. Don't try to figure out when it's 11. Move the 11 to the other side. You with me? Okay, so let me find a piece of paper that I can write on. Yes. Which one? The one we're getting ready to do, or the one we? This one? What x coordinate? How did I find it when it was 11? Or how did I find? Yeah, I did. That's why I'm. Yeah, I'm just really smart. Here's my function, right? 4 cosecant. If you don't like cosecant, right? Sine x plus 3, and I want to know when that thing's equal to 11. Fair? I want to know when it's equal to 11. And it's probably easier if you just move that 11 over here and set that stupid thing equal to 0. With me? And so now you have 4 cosecant x minus 8. Uh-oh. What are you doing here? Equals 0. And now I'm looking for the x-intercepts as opposed to looking for when it's 11. Little bit easier that way. Little bit easier that way. Okay? Still graph sine. You still shift it. You still expand it 4. And you still move it up 8 units. But you'll see easily where it crosses the x-axis then. I don't say easy, but easier. Okay? Same thing here, ladies and gentlemen. Set 3 minus 1/2 secant x equal to 4. Set it equal to 4. Move that 4 to the other side because we're going to find it equal to 0. So if I move the 4 to the other side, that goes with this 3 and makes it a -1 minus 1/2 secant x now equals 0. Whoops. Lake, I know I'm completely blocking you from everything. And so now when I graph this thing, I'm going to graph the cosine, and I'm going to just see when it hits my x-axis. Going to see when it hits my x-axis. So let me clear this out. I'm going to just assume you guys can do that, but that's bad. I'm just playing now. Secant, cosine, starts high. But this is shifted down 1 unit. So instead of starting high, it's actually going to start at 0. It's a half. The half just shrinks the period. Yes. Starts at 0. What did we say this one was? Cosine. Cosine starts high. Oh, it's negative. Oh, it's negative. So it doesn't start. It starts low. Starts low, goes high. Here's 0. Not 0, but this is this Inflection point. -1. I did all that. Did I move it down 1? Yes. No. Did I move it down 1? Yeah, no. Down 1. Max. Yeah, I'm sorry. Freezing up again in front of you guys. Y'all make me nervous. That's what cosine's supposed to look like. That's what cosine's supposed to look like. I don't have this. I got -1, so I'm moving this whole thing down 1 unit, down 1 unit. So now it's starting here. And then instead of going from 1/2, I need to shrink it first. I guess I need to shrink it first. Multiply before you add and subtract. I can't undo. Let's shrink it first. So now, now this is 1/2, and this is -1/2. Shrink it first. The amplitude is 1/2. And now move it down 1 unit. Now move it down 1 unit. Down 1 unit. That's 1/2, so it's actually going to start here. I can't get down that low. Asymptotes here. It's not helping me any. Hit me.
When we just isolate the secant of x.
Yeah.
And then
reciprocate it. I think we still got that same pi over 6 here. Oh, no? What?
What's going on? What did you say?
He's being a nerd. I got too many nerds in this class. I love you, every one of you guys, too. I need some of you girls to step up.
We should find the easiest way to find the answer.
What's up?
Secant of -1/2.
Secant of -1/2.
Or not secant of -1/2. But if we take this to the other side, you have the 1 and whole third side by. Wait. The -2.
Now I'm going to put the 1 on the other side. You with me? Put the 1 on the other side. Divide both sides by -1/2. Oh my gosh. What the heck? I didn't. It did. But yeah. That's what you were saying, right? Isolate this. -1/2 secant x equals 1. Multiply both sides by -1/2 or by -2. Multiply by -2. Secant x equals -2. Now I just need cosine. When cosine equals -2. Holy cow, that would have been a lot easier. Man, why didn't I think of that the first time? Where was this one at? Where were we at on this one? Where'd I do that at? Oh, up here. I wanted you guys to come up with it.
Well, after all that, I'm not following.
Want to add 8 over here? Divide by 4. See when it's 2. Yay. Whole lot better than doing all your shifting and all that other stuff I was trying to do. Yep.
I was just gonna say for the answer for
Oh. Was what?
if the cosine of x is equal to -1/2.
Which happens at
2/3 or
2 pi over 3. You're going to end up with those nice numbers unless you got a calculator one like this next one. Okay. Beautiful. Let's do this last one to make sure you guys can. We can't. You can?
Did you hear that, Mr. Mayor? Connor said he could do it by himself.
I think you should.
In the quiz.
That was,
Come on.
I think you should go. That was actually.
I think you should say that.
Who can do it by himself? What happens when you point fingers? 4 more pointing right back at you. Three, depends on how you use your thumb. Got to graph this with calculator. Probably no. Highly recommend Desmos because your stupid calculators don't have a cotangent button, they don't have a cosecant button, they don't have a secant button. You can do it. Just saying Desmos will do it better. Yep.
On our calculators, we use the invert.
Nope. Invert is not the same.
What do we use?
Do 1 over.
We have to do 1 over cosine.
So we can't do the inverse.
You can and get it wrong.
Okay.
That's 310 is the inverses. Inverses is not the same as reciprocals. But it's a common thing that students think that they can do. Y'all understand what he's asking, right? What he's saying? On the stupid calculators. You got that tangent, and then right above it, you got tangent to the -1. Tangent to the -1 is not cotangent. Sine to the -1 is not cosecant. Those are inverses. Inverses are not the same as reciprocals. We like to think that they are, but they're not. They're not even close. Inverses switches x and y's. They don't flip. Oh, yeah, that kind of makes sense. So I recommend Desmos. If not, then you're going to have to do sine. You're going to do sines and cosines or flip tangents. So this particular one, if you're going to use your TI for this, you're going to use a 3 because 3 is a constant. And you got minus, and you got 1.3, and then you're going to do 1 over tangent of 0.5x minus 1. Because that's cotangent. Or you can do cosine of 0.5x minus 1 over sine of 0.5x minus 1. Desmos will do cotangent. You don't flip. Oh, this is 1.7. I see why everybody's looking at me weird. Sorry. Okay. You don't flip the 1.7. The only thing you flip is the angle. And the angle is what you're taking the cotangent of. In the xy plane where the x coordinates of the points are P equals 2. You want this equal to 2, but the easier thing to do is to subtract 2 and set it equal to 0, and then you only have y1. And figure out where it hits the x-axis. That's easier than trying to figure out where it hits 2, but you can do it either way. You'll have homework tonight that you'll get to practice that with. Either practice it with Desmos, practice with your calculator. You may want to practice with both because test day, you may forget. I don't know. I haven't used Desmos much at all, but my little calculator I use has tangent, cotangent, secant, cosecant, sine, it has them all. TI doesn't. I don't know why. I think it gives students with TIs a disadvantage. Yep.
It's saying x coordinate, but I'm only getting one coordinate.
There's only one of them between 0 and 2 pi?
Yeah.
So make sure you change your window from 0 to 2 pi. There may only be one. I don't know. What'd you get?
I got 4.0781.
Where am I at? Unit 3. Good gracious, come on. Unit 3, 3-point worksheets, warm-ups, notes. This is what, 311? Key. .0781. That's all I got. Make sure I'm changing my rules. Ain't no longer 3 decimal places. 5. 5. Because some of you knuckleheads won't take it out 3, and you got it wrong every time. One of you knuckleheads decided to put like 0.8 pi over something and then changed it to a decimal, and you only put 2 decimals. And you got it wrong because you only put 2 decimals. So, 5. If you don't take it out 5, I'm taking off. Yep.
Let me check the answers for the last two. Or the two before this one. Just to make sure.
Example 6.
Examples 6 and 5.
6 is 2 pi over 3 and 4 pi over 3. Another one was pi over 6 and 5 pi over 6. That's what we said on both those, right? I don't know if we finished that one example, but we for sure said pi over 6 and 2 pi or 5 pi over 6. There's a bunch of ways to do those. Understand that too. Okay? Beautiful. Any questions? Your test, they should be done and put in. They should be done today. I mean, I'm done. I just hadn't. I got to wait for the other teachers to get done. Yep.
Our practice tests or our weighted tests? Our curve tests?
I don't care about a curve. I'm done with your tests. Computer does that part of it.
If you could just like take a goosey gander at like what the curve would be, you say it's like pretty like.
I don't do anything. It does it.
What was this difficulty of this test out of 10?
The difficulty of this 10?
Yeah.
I don't know. You tell me. Y'all took the stupid thing.
Well, you said it was harder. You saying these tests are easy.
I thought it was easy.
Okay, so the curve won't be very much.
I mean, I got 100.